When you want to train a decently accurate neural network, you need massive amounts of data. But sometimes you don't have that much. Maybe you want to train a good image classification network, but you only have 50 images. This is the ideal scenario for transfer learning, where you train a neural network on one task and then fine-tune it to perform another. This can be valuable, for example, of course, like mentioned, when you have a small data set, maybe of dog images, and you have a large data set of something else, maybe cat images or images in general. So you can train your model on that one and then fine-tune it to perform better on the data with the dog images, assuming that the knowledge it gains from the source domain task is helpful and valuable for the target domain task. But transfer learning does not only have to be used if you have a small target domain dataset. It is also generally a good idea if you don't start your model with random initialization, but with a pre-trained model. If you use transfer learning, your model will generally perform better than if you don't, even if you have a sufficient data set on the target domain. And to see if it works well, I programmed 2 neural networks to experiment with this technique. In my first experiment, I fine-tuned Resnet18, which is a large popular computer vision model, and I used that for labeling images of ants and bees. The first way I did this was by importing that model and changing the last layer of it, so the output layer, to only have 2 outputs, 2 neurons, either ant or bee, and then I trained that whole model, which I created, on the new dataset of ant and bee images. The second way I did this was pretty similar. I imported the model, I changed the last layer of it to only have 2 outputs, but when I didn't train the whole model, I only trained the last layer of it. So I sort of freezed and fixed the parameters of the layers before, the convolutional ones and the first ones of the neural network. Both techniques worked extremely well, and my models were able to differentiate between ants and bees very accurately. In my second experiment, I fine-tuned the mask RCNN by Meta and used that for segmenting and detecting pedestrians in images. The way I did this was first by importing the mask RCNN, then training it on the Coco dataset, changing the last layer, and then I trained that new model on the Finetuning database for pedestrian detection, which is a small dataset with images of roads and images where the pedestrians are segmented from the rest, as you can see here. Because the dataset was so small, I only fine-tuned the last layer of it, and it managed to detect the pedestrians better than expected. Still not 100% accurate, but for this size of dataset, it managed to do a very good job. These were my experiments with transfer learning. I wrote an article about them, which I link in the description below. If you have any questions, feel free to ask, and bye.